So by next week, you need to submit the first lab. In this lab, we are going to be familiar with the data mining tool. There are a lot of the available data mining tools in the market, or the open source, and for educational purpose. The Weka is the open source. It's developed by the University of New Zealand, I guess. The name of the Weka is followed by the name of animal. So this is a Java based. You don't have to worry about even though you don't know the Java. Just download and install. Then get familiar with how to use that tool. At that time, what you are going to do is this. First, you can install the Weka by following the instruction. I think I have also instruction, but I don't have to provide you, so you can just follow the instruction on the website. And then it's already most of the well-known data mining tool algorithm are implemented in this tool, so you don't have to re-implement by yourself. But sometimes you can use the existing library to enhance your own algorithm or to develop yours. So many of the people are using this one. Also, this can be used for your reference. Okay. Also for testing your data. So in this project, we are going to use the data set downloaded from the UIC. So if you go to I'm not sure whether that website is the correct one. They recently innovate the website. UCI database. The UCI database is one of the popular machine learning repository. So you can, when you read the technical paper or the published paper around the data mining or the machine learning, you will see a lot of the references that the site mentioned about the UCI, the database. So if you go to the machine learning repository, you can see even January they update the new data set. So you will see a lot of ALICE data set, which is one of the most popular data set. So you can select at least 3 data sets from here. So there are more than 300 data sets, but there are more. So you can find more if you place the view all data set available. One of the benefits of using such the UCI data set is sometimes some of the algorithms are biased to the data set itself. So I have the new algorithm for the clustering, but this one is working very well for my database data set. But when I apply this one to other data set, it doesn't work. So to compare the new algorithm, so we are going to use the common data set. This is one of the reference data set. So why don't you select, based on your interests, why don't you select at least 3 data set from here, the download. Some of them directly you can use, but sometimes not. So if needed, you need to do the pre-processing based on our knowledge that we discussed last time. So you can prepare the data set. So Weka has their own format, the AFF format, or you can use the CBS commercial free the value. But anyway, so you need to do the appropriate pre-processing to run the Weka algorithm based on your own data set. Then the next step is based on the knowledge that we have learned last week, and also today we are going to discuss about mostly how to make the efficient algorithm for the association rule mining. So pretty much we already discussed about how to find the rules for based on the association rule frequent data mining. So using that knowledge, why don't you find the rules based on the result of the Weka? Okay. But sometimes it's not easy to use it directly, so you need to get familiar with this tool. Okay. but I don't think it takes, it's very difficult to understand. It's a very simple, the interfaces you can try. So output of the this project is that just you don't have to submit any source code or anything, just install and download. And so throughout the semester, whenever we cover, for example, today we are going to learn about the clustering algorithm, and for example, the k-means algorithm, k-mode algorithm, the memory algorithm. So at the time you can test it with the webcam. Okay, so it's so you can use this tool to get familiar with, to understand about the data mining algorithm throughout the semester. Yeah. So using the PDF format or Word format, you can submit including the objective and about your data set. Okay, and probably you need to adjust. Okay, which means you need to give the different value of the parameter. So what is the best parameter or the data set and why, and then finally what is the rule that you can find from there. Sometimes it's very subjective, even though we are going to apply the confidence level, but at the time why it is the 60% confidence level or something like that. So why don't you summarize, conclude your work based on what you learned in this project. Okay, so any question regarding to this one? So you don't have to implement anything, just download and install the Weka. Then first you can use the, when you install the Weka, there exists built-in the data set. You don't have to download and include. You can use the test using the existing included the data set and test it and see what's going on. And also, probably if you are interested in the more algorithm about the data mining, you can test it. Not only just the association rule mining, what about the clustering that we are going to discuss today, or the classification, or if you want to use the data mining technique for your research or for your project, so you can test it simply with the Weka. Also, if you are interested to enhance the clustering algorithm itself, okay, at the time you can use the Weka for your implementation simply. So it's a Java-based, it's a Java program. So if you import the class file, then you don't have to implement all the things. Sometimes you can just modify the code. Okay, so that is the first project, and in the second project, this is one of the way how to be familiar with the data mining technique. But sometimes if you are involved for the research project, or especially for your dissertation or the thesis, so you should be able to implement the data mining algorithm. So sometimes such a Weka or the existing data mining tool doesn't fit exactly to my research. So most of the time, many of the researchers, they implement by themselves, even though they are applying the exactly same algorithm because of the different data types. For example, my data set has the 12 features, sometimes dynamic features, sometimes a very high dimensional feature, so which are not feasible to the Weka or the existing tool. So you should be able to implement by yourself. Okay. Also, sometimes the manual adjusting the parameter value, so you can, and it's not possible. So you need to test automatically, so from 0 to 100, and see the result and try to find. Okay. At the time, you should implement by yourself. So in the second project, after we complete the clustering algorithm, you are going to implement the means algorithm and their variants, K harmony means or the K something means algorithm by yourself with your own code. At the time, you can use the Java, you can use the C, C#, it doesn't matter, as long as I'm going to focus on whether you can implement the algorithm with your own code. Then third one, I don't decide yet. That's one thing we need to discuss every class throughout the semester. Right now, the third one, I'm thinking about the data mining project for each student. So each student will select the topic. So first the data set. First the data is set. Then find the data set, and based on the data set, we are going to find the objective. What we are going to analyze. What is the expected output. For example, I try to make the cluster by the customer group. So I'm interested in the customer sales data. So because my family has the business, then why don't you collect the sample data and understand your data? Then after you understand and after you decide it, why don't you make the data set? So data set probably is bigger than the sample data. So after we make the data set, so you are going to pre-process. So if there's any missing data, you can revise or change the value for the missing data, and any transform that we can apply. And after that, what is the objective? You are going to decide the goal of the data mining. So at that time, you don't have to decide which algorithm first. Just what is our goal by analyzing this data. You see, prediction is kind of the cluster or make the group for the VIP group or just the normal group or whatever. Then the next step is you select one of the techniques that we are going to learn throughout the semester. And last step will be implementation. At that time, for that implementation, I'm thinking about the specific data mining. It's not data mining languages, so I'm thinking about the statistical tool for the R programming, which I didn't use in my previous data mining course. This is the first time, so I'd like to use. After we have a couple of times a lab, I think the one time maybe enough, it's not very difficult. The R programming, so all the students will use the R programming to implement the algorithm at the time. So you can use your existing algorithm, or you can enhance, or you can use the different similarity or dissimilarity algorithm, or the many variants are possible. But so we'd like to use. Also, our program provide some package for the data mining. So you don't have, if you are focusing on the specific data set and find the model, at the time you can use the existing data mining technique. Or if you want to implement it by yourself, then you can do that. So that is what I'm thinking throughout semester. So by next week, in addition to the lab, this is just a lab, the given assignment. By next week, why don't you think about what kind of data are you interested? Okay, so it can be anything. I'm interested in the social media data. I'm interested in the biomedical data, or the sales data, or the stock market data, or the web page, web log data. I'm managing the web service. I'm the webmaster. So I'm hosting the personal web pages. So every day I have at least 100 users and 1,000 transactions. Probably in your web server, there might be the log. So that log, that includes the very important information of the source and source IP and source computer that access and the browser name or something like that. So I'm interested in such the analyzing transaction data. Also, I'd like to make my own data set by implementing some program. So sometimes some of the social media websites, they provide the API, so you can actually create your own data set. So why don't you think about just it? And if possible, why don't you copy and paste or download some less than 10 the record, less than 10 transactions, less than 10 the data, sample data, okay? So output of the first step of the term project is the finding the data, okay? That is our goal. So do you understand what I'm saying? There is no specific requirement, so you can find based on your interest. So if you are doing the research for specific data set, so you can use such a data set for your interesting data. Or it doesn't have to be just numerical data. Sometimes it can be the image data. Image also can be the data and the data set for data mining technique. And also sensor data, yes, sir, it can be. It's a bunch of the number from the source of the sensor, so it can be whatever. It doesn't have to be just like the formal data set, like the UCI data set. That is UIC, UCI. Every time I use UCI, it's the name of a university, right? So UCI, it's the University of Chicago at Illinois, right? California? I think it's
Chicago.
It's Chicago, right? Yeah, UCI. I think the University of Chicago is Illinois. But that is a formal data set. It's a very well known, but you don't have to stick on such a formal data set. It can be even unstructured, semi-structured data set may be possible, like the web pages. Okay. Later we will discuss how we can make the structured data, or how can we handle the unstructured data or semi-structured data. So I'm dealing with just the document itself, even that is not XML. But at that time, we can classify, we can cluster based on the frequency of the word, which is very, very popular. So frequency-based approach. So why don't you think about the more creative, so bring your idea. So I don't think we had the presentation, all 23 students. I'm going to select 5 random. Okay? So then, the beginning of the class, I'm going to, so every student should be ready. So that is the limitation. I'm trying to my best to minimize. So usually I have the 10 to 12 students in the previous data mining classes. So many of the time we can discuss together with the problem. So that will be very, very helpful. But this semester, even that was hard to keep the maximum 25 students. So right now I have the 23 students. So I'd like to hear from all the 23 students and discuss, but it will be probably the overnight. So I'm going to the point, the 5 students. If you so just I'm going to create the assignment on Canvas after this class. Then you can submit the. There's no limitation, but it doesn't have to be long and formal, the documentation yet. So 2 or 3 pages of the PPT file is enough, okay? Even not the Word file. So why don't you think about if you cannot make the right now, so you don't have to prepare the sample data, just manipulate the data that you imagine is better. Sometimes you can make the data set by manipulating or by coding your program from the multiple sources. So why don't you imagine and think about your data first. Anyway, we are dealing with the data, so we should start from the finding the data. It is okay if somebody gives the task to you, then you can solve the problem, but this is the course that we are going to learn. So why don't I think that this will be a good opportunity to understand your data. So first, think about, and also with the help of Google, so you can search. But many of the existing data sets are the very formal, well-known, and very simple. So I'm expecting some the creative idea about even social media data is nowadays very popular. So even though we are going to use the couple of the social media data for understanding the R programming later, but the social media data, not just the Facebook data, but in web and the social media data, there might be more information. Like for example, it is still the challenging problem, like how to classify the personal information in your cell phone, right? So if we can classify by connecting the email and some other Facebook, can we consider both of them? So sometime probably when I receive the email from the bunch of sources, so if we can find something something reliable information from the social media data like the Facebook, that can be the regular email. Otherwise, if we cannot find the source of that, so it's a spam. So at that time, if we can collect think about such a data, it can be the application of the classifying the spam mail using the social media site, whatever. So the first step is the research the data for the term project. Okay, and then if you can find the sample data, it's okay. So you can copy and paste and explain about it. You don't have to decide the objective of the data mining or whatever. Just the data itself. Okay, so then at the beginning of the next class, I will select 5 students to share the idea. At that time, if you miss that, it will automatically fail, even though you are lucky, but it will be graded based on your submission. Any question? Okay, so that is did I upload this file? Did I upload this? Can you find this one from the canvas? No. Just for your understanding, I think that this one is not the latest information. It's I think a year ago, but maybe similar. How to install the webcam. I think the name of this one is the webcam. Is it New Zealand? Yes, it's New Zealand. I will check the canvas. If not there, I'm going to upload this one. So today we are going to continue the pattern mining, the association rule mining. Last time we have talked about the priori the algorithm. The idea of the priori algorithm is based on the previous knowledge. So after scan the data set, we try to select the item set that satisfies with the support. The support means the minimum number of frequency. Anyway, this association rule mining or priori algorithm is based on the frequency. And then based on that, we can have the candidate. So there are 2 steps. First, we are going to scan, and then we have the candidate that satisfies with the minimum support. The minimum support in this case of 2. Then we can have the candidate and join again. Then we can make the 2 item set. Then the scan again. Then repeatedly until we have the final one. Okay, that is the priori algorithm. Problem? What is the main problem?
Number of scans.
Yeah, number of scans.
It's
It's a very expensive operation. We have to the 2 scan at least every interface. So that is a problem. So we try to address such a problem. There are a lot of the barriers. Before that, to make the rules, so using the confidence. So also we need another the parameter value, the threshold value. Probably you will realize you need to set the different confidence level, different support level when you are using the wake-up program. Okay, see the difference. So we can make the rules with the confidence. So in case of B, so C and E. So with the confidence level 67% and something like that. This is our priori algorithm. It's traditional the association rule mining. Then the main problem is the efficiency. So most of the variants of the such a association rule mining is how to improve the efficiency. So first one is FB growth. FB growth is we are going to make the tree, which means the idea of the FB growth FB tree based priori the association rule mining is if the small item set are frequent item set, then that can be there. That can be used for suffix of the bigger item set. That is the idea. Okay. So for example, if A and B is a frequent item set, it's a minimum smallest item set, then the other item, the frequent item set will include this one. Then we can start from the such a the small item set to find. Then such a relationship can be connected using the FB3 so to reduce the number of databases scan. That is the FB growth, and the vertical data format is our data set is the for each transaction we have the item. So why don't we other way? So which means the number for each item we will check the number of the ID, transaction ID. Okay, then we can increase the performance because comparing to the number of transaction, we have less number of the item. So Walmart maybe the millions, billions of the transaction, and the how many items? Maybe the less than millions, right? So it's much less. So that is the idea. Then also mining close frequent pattern and using the max pattern. I probably last time because of the Tylenol. So actually after the last class I got flu. So this is the first time to come to UB after the last class. So I missed the whole entire week because of the flu. But fortunately it is not positive. It's a negative for the H1N1 or the swine flu. So it's just the seasonal flu. But it was my first time to the Tamiflu. Is there anyone who ever took the Tamiflu before? No? So I even never seen the Tamiflu, but anyway, but it's recommended if you do not take the Tamiflu after you got infected by the H1N1 or the variation of the H1N1 or swine flu, you may die. There's a very high possibility. So you should, just in case, take the, even though seasonal flu, until you are waiting the result of your test, it's better take the Tamiflu. Okay. So at the time, I got confused with what is the close and pattern and the max pattern. So we will see the difference. At the time, I missed the support, the number of support, the close pattern, the width, the number of support. The maximum pattern doesn't consider that. Then at the time, why don't we consider only the close pattern and maximum pattern for mining? Because that is a kind of boundary maximum, so we can focus on that one. So to reduce, to increase the performance. So this is the idea how to improve the performance of the priori association rule mining. Okay, as you can see, the problem is that anyway, first it's too many transactions. So solution, you can reduce the number of transactions. How can we reduce the number of transactions? Sampling. Okay, to find the pattern, that is one of the. We don't need a huge amount of data sometimes to find the pattern. That pattern, for example, during the presidential campaign, you know the Quinnipiac is the well-known the institution for the poll to guess who will be the next presidential, something like the Quinnipiac University, one of the nationwide famous the institution to do such a poll. So at that time, how many people? Can you perhaps check? Only 1,000 or even less than 2,000 people. Then they can guess what is the percentage of supporting the Obama or what's the opposite? Mitt Romney last time? So Romney, something like that, 48% versus the 51, something like that. Even we check the 1,000 people or the 2,000 people, we can guess. Okay, so that is the power of the statistic and also sampling. So we can get the idea of such a reducing the number of transactions with the sampling, or why don't, if there are a huge number of candidates, we can reduce such a number of candidates, something like that. Okay? So also, if that is too big, why don't we partition? Okay, by like this. So this is the idea of using the hash-based algorithm. So for each hash table, using the transaction and the entry, so we can make we can apply the hash function. So by applying the hash function, so we can, each bucket has the item that has the same hash key. Okay. So what is the hash function, by the way? And surprisingly, many students, even though they heard about the hash function, they do not understand what is the hash. What is the hash function? Unique number. To identify. Yes.
As soon as it takes an input and will, based on an answer, it will always give the same input to the file.
Function of data. The data.
It's a function.
It's a function.
The
For
data
what?
itself.
It's like creating the fingerprint of the anything.
Create what?
Like the fingerprint.
That is the application.
It's a one-way function.
It's a one-way function. That's important.
That takes the data
Huh?
and produces a digest of the data.
Digest data. Yes. Which means
Cannot be inverted. You cannot get the.
no. It's a one-way.
A mapping function.
To make long size data into
Smaller.
okay, like
Device.
digest the data size data. But when we do something, probably it's kind of a trade-off. If we can make such a long size of data into short, we may lose some information. That is the one of the drawback of the hash, or it can be a benefit of the hash because it's a one way. It cannot be recoverable, so it's secure sometimes more. So one of the well-known example of the hash function is
Undefined.
modular. Divide by 10, then remainder, which means we can have the 10 hash bucket. So hash key is 0 to 9. So any number, billions, trillions, even the string, we can convert the string into the ASCII code. Then we can apply the hash key. So any number, any data, any size of data, either 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 1, 9. So very simple hash key. So benefit, so if we have whatever the data is, apply the hash function, then depending on the hash key, we can the data will be allocated, stored at one of the hash buckets. Okay, 1 of 10. Okay, then when we search the data, we don't have to compare entire data set. Instead, apply for the query, so we can apply the same hash bucket, a hash function, then find the hash key, then only the bucket that has the same key. How much you can reduce the search area? Only 10%, 1/10. It's huge. That is the reason in the database system, in the search mechanism, hash has been used a lot. Okay, but it's a one way. There are many problems, several important problems like the overflowing or the chaining. or the something like that. But still uses the same idea. Instead of the scan or search entire data, apply the hash function, then only focus on the hash bucket that has the same key. So that is the DHP is the hash-based algorithm for mining association. That is the idea. For the sampling, so we can sample, but depending on the how to sample the data, it may be different, but there are different ways, so I'm not going to cover details of it. Also, we can reduce the number of scans by considering the dynamic item set, the counting. I don't use exactly the same of this one. The idea is instead of from the 1 item set and 2 item set, the 3 item set, the finally 4 item set. At that time, we actually make all the combination of this one. But in DIC, the dynamic item set counting is starting for the D, A, D, and one way. We are going to find the one way dynamically. We are not going to consider the other. That is the kind of the DIC. But most popular one is the FP growth. FP growth is the kind of depth first search, which means we are going to find what is the one item set. Then try to connect the other item set that is based on that the item set is that first. So we will see. The idea is here. So if the ABC is the ABC is the frequent item set, and then if D is the local frequent item set, ABCD is also frequent item set. So we will see the example of this one. We are going to use the same the sample data set. Transaction database. It's not. Oh yes. So it has 5 transactions. So we have the F, A, C, D, G, I, N, P. Okay. So and so on. So at this time, the first step is we are going to make the frequent list, F list, which means based on it's the same as the a priori. So we scan the database, then check the frequency of each item. So the minimum support is in this case 3. So we have the FC, AD, MP, 44333, and this is called the frequent list, the frequent or the F list, like that. Then what is this? We can build such a FP3 based on the frequent item set. So for example, so P3, right? Where's the P3? So P here, P here, P here. So because the minimum support is 3, always 3. So we have this one, this one, this one. At that time, the upper level, okay? So P has how many P are common with the N? The next one. So we have the Pn and Pn. Okay, 2. So we have the 2 of the N. Then we can make such a upper node. And still 2 of the P is used with another one. One is BP. So B is the next one, so BP. So 1 of the B is used, and 2 of the N is used. So P is done. Okay, then we connect this way also, and build the bottom to top the tree. So second is N. 2 of N is used already because of the P, and there's another one N here that has the B. The next one is a B, so 1 of the B is used. So next one is a B, 2 of the B. One is used, where's another one? It's FB. So above B there is a F. So F1. Okay? One of them is used. Okay, then PM and the BM above that. So B is done. 1, 2, 3. Okay. Then what is the next one? A. So what about the A? A
3 times.
A is a 3. All of them has the C. Okay. Above C it has, and also each A include either M. Okay. 2 of the M. P include, and B1, BN, there's a B, B and M, 2 of MP, this one transaction 100, transaction 500, so they can be merged into A3, okay, things like that. And what about the C? C, we have the 4 of the C, the 3 of C actually include A and P, 2 over A and P, right? And A, B, M, A, B, M. So 3 over C, all of them has the A, so 3 of them include this one, then 1 of them is a C, B, P. Okay? Then by combining B1 and the C1 is a F, so this is a 4F, and finally it's a nothing over there, it's a top root node. So we can construct such a FP3 based on the F list. Okay, so this is the algorithm to build the FP3. Okay. Then to find the frequent items and using the FP3, so it is based on the conditional, the pattern base. So we can start from the bottom one, P conditional. So using the P conditional, if the P is the frequent item set, then all above, like the F, C, A, M, that include P. So how many transactions that include F, C, A, M, P? It's a 2, because this is a 2. So P conditional, the pattern is 2 of F, C, A, M, and also 1 C, B, P. Okay, so based on P, there are 2 conditional pattern. That is called the conditional pattern base. The FCAM, 2 of the FCAM, and the CB. Similarly, for M conditional, the pattern base, so M conditional, FCA. Okay, how many? 2 of them, FCA, and M is another one here. So FCAB is 1. So similarly, B is connected. You can go to here. How many? FCA 1. So 1 of the FCA, and B is here 1F, and another 1 here. So it's a C1. And A conditional base has the A is going to here. All 3 are here. So FC. So 3 of them. And similarly, C is a F, 3C, but the C is the top, so C is side. So this is called the conditional pattern base. P conditional, M conditional, B conditional, and A conditional, C conditional. So in case the P, if we are looking for the pattern, the frequent pattern that include the P, you can use this one. This is not the frequent pattern yet. We need to find the sub-frequent pattern. So sometimes it can be FC, P, FA, P, something like that. So for each pattern base, so in this case, this is the M conditional. So M conditional we have, so FCA, 2 of the FCA, okay, then 1 of FCAB, okay. At that time, that is the 2 of the FCA, 2 of the FCB. So we can find as many combinations as possible. So that is the FM. So FM is possible, and CM, AM, okay, FCM, FAM, and CAM, FCAB, FCAB. But at this time, so if we consider the this is the M only for this one. So we do not consider this only for this. Okay. So that is the sum the old frequent pattern that are based on the N condition. Okay. Then we can find the FCA. So that at that time, if we apply the minimum support with the 2, for example, minimum support with the 2, so at the time we can have F, is it 2 or 3? Hold on.
3.
Oh, it has a minimum support of 3, okay? So it, for each the M conditional FP3, we can have FM. At that time, we can apply the confidence. So based on the N, so if we have the confidence level is a 2, then so this one FM is the more than 2 is a 2, and FCM and AM is based on N. So FC, FA, all of these can be considered. Okay. So minimum support 3. So all of this can be considered as the condition at the frequent pattern. So idea is that if this one is the frequent one, then there it can be used for the prefix of the frequent item set. Then at that time we don't have to scan every time. Instead, using such a FB3, we can find the subsequent frequent item set. Okay. However, it depends on what is the conditional pattern based. If we consider conditional pattern as the AM, it will be FC conditional FP3 from here, so we can find FC only and or F only. But based on that the base pattern. Okay. So that is the FP3. So even we can sometimes, even though we are going to reduce the database scan using the FB3, but what if our data set is too huge? So still, at that time, FB3 itself is very big, which is not enough in the memory. So sometimes we need to reduce the size of the data. The one solution is the partition based. So we can partition by the conditional, the base, like the P base, the N base, the B base, and something like that. We can the partition, then apply the parallel, the processing for each partition. So that is a partition based projection. So this slide shows the how much efficient comparing to the a priori algorithm for the FB cross 3. Okay, you can see the runtime is slow, much lower, and with the different support level. There are variation of the such a FB3 and FB gross. And the E-clap, so that use the opposite way. So instead of the transaction, for each transaction we have the number of items. So we will consider the for each item the number of transaction like this one. This is a vertical format. The idea is that we have the less number of the item comparing to the number of transactions. Okay. Then